Hello everybody, welcome to Northern's Craft. So today we are going to talk about laws of thermodynamics. Laws of thermodynamics. It will be a short nutshell. So there are actually four laws of thermodynamics. Zeroth law, first law, second law, and third law. So let's start with the zero law. Let's say if there are three bodies, body A, body B, body C, A, B and C. If body A have a temperature T dash and body C has temperature T dash, and if we say temperature of A is equals to temperature of C and temperature of A is also equal to temperature of B, this implies this temperature of A and C are barabar hai, which implies temperature of B and C is also equal. Temperature of B and C is also equal. Basically, zero law of thermodynamics deals with like relates to the law of transfer of thermal energy. So this is zeroth law of thermodynamics. You can understand by this. So now let's talk about first law of thermodynamics. There are two things that we need to remember. One for cycle and process in case of first laws of thermodynamics. In case of cycle, summation of work done will be equal to summation of heat, and in case of process, heat transfer will be equal to energy plus work done. So let's understand this one by one. Let's understand first for cycle. So let's talk about first law of thermodynamics for the cycle. Okay. This is a PV graph. This is 1 point, this is 2 point. 1 point, 2 point. Let's consider A, B. Heat transfer in rod A 1, 2 plus heat transfer in, let's consider this rod, okay. This will be the rod, okay. In rod 1, B 2, or let's say 2B1 is equal to work done in 1A2 plus work done in 2B1. So this clarifies that, implies summation of Q is equal to summation of W. So this is first law of thermodynamics for the cycle. Basically, first law of thermodynamics is law of conservation of energy. Now let's understand for the process. Let's consider there is one container, okay, and it's a closed system. So heat is transferred over here, and it is like going against this. Let's consider we gives 1000 joule of work, okay, and work is producing in 500 joule. But now we see where this rest energy goes. 1000 joule, it needs to be 1000 joule, 500 1000 joule need to be output now, but that is consumed by E, which is equal to W. So which implies Q is equal to D plus W. So this is the thermodynamics for the process. First law of thermodynamics. Basically it is law of conservation of energy. Now let's go to second law. Second law. Actually second law says actually, by the way, not it says, it introduced the concept of entropy, and it says basically not all energy transfer are efficient. For example, let's consider a waterfall. Okay, if this is a mountain and water is falling from here, consider. Now it's not feasible for water to go above. This is what first law of thermodynamics says. So second law of thermodynamics basically says like everything goes in a randomness, and the randomness of universe is always positive. The change of randomness of universe is always greater than 0, or always positive. Always positive. The basic formula for this second law of thermodynamics is del S upon T is always greater than 0. This is the basic formula for the second law of thermodynamics. So there are Kelvin-Planck statement as well, which says that heat can be transferred from that is Coulomb's statement. This is second Kelvin-Planck statement, which says like no machine is possible to perform better than the perpetual machine. Perpetual machine is a machine which gives if we like put over here 100 joule, it gives the output of 100 joule. This is perpetual machine, and Kelvin-Planck statement says that no machine is more feasible as perpetual machine. This is also the definition of second law of thermodynamics. And now if we go for Kelvin-Planck Coulomb statement, Coulomb statement says that heat can only be transferred from hotter body to cool body, not from cool body to hot body. To transfer cool body to hot body, some work done need to be done. Okay, so this is the statement for the second law of thermodynamics. Now let's go for third law of thermodynamics. Third law. It helps us to understand the behavior of the material at very low temperature. At very low temperature, it helps us to understand the material behavior. Third law of thermodynamics. So actually what it says is, if absolute temperature reaches to 0, then entropy also decreases, randomness also decreases, but randomness doesn't become 0, it is unattainable. As I say, randomness is always greater than 0, randomness always decreases. So basically what it says, if the temperature goes to 0, then the behavior of particle also decreases, entropy, randomness also decreases. And this basically helps us to understand the material at very low temperature and help us to study the quantum states. So these are the 4 laws of thermodynamics: first law, second law, and third law, and zeroth law. So we have studied zeroth law, first law, second law, and third law. We can say zeroth law is relates to the law of energy transfer of thermal energy transfer. First law of conservation of energy. Second law says entropy of the system never becomes less than 0 or negative, always positive, and never becomes 0 entropy of the system. Third law talks about the when the material reaches very low temperature, then the entropy also decreases, and but entropy doesn't become zero and helps to understand the quantum states. So that's the explanation for today. Thank you very much for seeing this video. Hope, please, if you have any doubt, please you can ask in the group, ask in the channel, and please comment and please subscribe. It will help me to grow my channel.